Hello, welcome to Mtari TV. Welcome to Mtari TV. Just wanna say thank you for watching Mtari TV. Don't forget to like the video and leave a comment and subscribe it as well, and share it to others so that they can be helped as well. Okay, so in today's video, we're going to look at physics, pure physics, which is physics 50, 54, or physics 5 or 54. Okay, so as usual, this video was requested by Miriam. Requested this video of a 2025 GCE Pure Physics question number 5. Okay, so looking at the comment, we have Miriam there commented about 7 hours ago requesting a question on question number 5. So this video was requested by Miriam. You can also request your own video here at Mtari TV so that we explain the best way to answer questions in physics. Remember, because here at Mtari TV we make what? Physics easy. That's our point of this channel. We win when you win. So let's help Miriam with question number 5. Okay, as usual, we always respond to our customers here at Mtari TV because we win when you win. So if you want, you can also leave a comment on this video or any other video on Mtari TV on requesting any question from 2016 up to 2025 GCE. Any question, be it paper 1 or paper 2, or you can just leave a comment and that video will be made for you, like this one for Miriam. She commented on one of our videos and she has gotten her video. You can also do the okay. So what we do here is so let's look at the question for Miriam. So Miriam picked question number 5 on the 2025 GCE. So question number 5 reads, pressure in car tires must be kept at recommended pressure levels. Tire pressure is monitored regularly so that the required action is taken if the pressure is not at the correct level. So question 5A, numeral number 1, says define pressure. Okay, so pressure, this is the amount of force acting per unit area. This is the amount of force acting per unit area. Let me just get my text here, or not, I'll just type it. The calculations, I'll write them. So pressure is the force acting per unit area. Okay, so that's how you define what force. So we move on to the next question. Let's look at the question B. Okay, let me just move this in front so that it should be visible to everyone. Just move it right here. Yeah, so that's how you define what pressure. So pressure, pressure is a force acting per unit area. So question A2 goes on saying, derive the SI unit for pressure. Okay, deriving the SI unit for pressure. So when you want to derive the SI unit for pressure, what do? When I say derive, you're simply asking you to make or to show the steps on how the SI units for pressure came about using the basic units like meters, seconds, kilograms, all those things, grams and kilograms, like grams and all those, using the basic units so that you can make the SI unit for pressure. So we know that pressure, I'm just trying to write it here. We know that pressure is equals to what? Force over area, right? I think here I won't have space. Let me try to do this. Remove some space here. Okay, some space for the right question. Okay, as I was saying, we know that pressure is equals to force over area, right? So now what we're going to do, the next step, we're going to use the units for what? For force. You know that the units for force is what? Newtons. There is no other units for what? For force. So we're going to use units for what? For force there. Then we know that area is meter times meter, right? When I said derive, what they are asking you is simply to make the SI unit of pressure using the basic quantities. Okay, the basic quantities, these are just simply units which cannot be made from other units. For example, you have seconds, grams, and the meters. All these units cannot be derived from other units. So that's what we're doing here. I'm using m, which stands for meters. We know that area is meters squared. That's where this m times m has come from. Okay, let's move on. We know that when this happens, when you have force, when you have newtons divided by m times m, we're going to give us what? Pressure. And you know the units for pressure is equals to what? Pascal. Okay, so we can safely say that just use this part here. Hope I haven't lost anyone on how to derive the units for pressure here. So we can say newtons, right, over m by m. Let me just get my pen. By m is equals to what? Pascal. And just like that, you have derived the units for what? For pressure. I hope Miriam, this question or this video is helping. You can also comment and request any video of any question from the 2025 GCE, and we'll definitely make it for you here at Mutare TV. Remember, this video was requested by Miriam. I hope Miriam, this video helps you Okay, so we move on to the next part of the question. Okay, so question 5b reads, figure 5.1 shows an instrument for measuring pressure. Atmospheric pressure acts at point Z, and the gas pressure to be measured acts at X. Okay, so we have a diagram right there. So the question goes on saying, explain how the pressure at X compares with B1, the pressure at Z. So what do? We know that the higher the altitude, the lower the pressure. The lower the altitude, the greater the pressure. Okay, so this simply means that the pressure here at point X, just get my pen. This simply means that the pressure here at point X is greater compared to the pressure which is at Z there. Why? We follow the principle which says that the higher the altitude, the lower the pressure, and the lower the altitude, the greater the pressure. Like in liquids, remember pressure in liquids, as you go down the liquids, as the depth increases, so that does the pressure increases. That's the concept you're supposed to use to understand or to answer that part of the question clearly. Miriam, I hope these explanations are making sense to you and they are helpful. So like I said, pressure at X is greater than pressure at Z. A reason I've already given, saying that, let me just type it in for those. So pressure, you say pressure, just move this a bit. So you say pressure at X is greater than at Z. The question did not ask for a reason, so we end there. Let's expand this a bit and put it in there. I hope you see visible. Okay, so we have answered what? We have answered question B1, saying explain how pressure at X compares with the pressure at Z. So the answer is that the pressure at X is greater than at Z. So moving on to question B2, the question says, explain how the pressure at X compares with the pressure at Y. Okay, so we know that when they are particularly simple ways, you can simply say that we know that if you look at the position of X and Y, you will notice that they are at same altitude. Okay, when they are on the same altitude, it simply means that the pressure is also at the same. So your answer there, Miriam, will be, just get my keyboard, I type in the answer. So your answer, Miriam, will be pressure at X is equal or is pressure at X is the same as the pressure at what? At Y. Just like that, you have answered. Okay, so we move on. Let's try expand this a bit to on this side. Okay, so what do we do here? Sorry about that. So your answer at B2 will be pressure at X is the same as the pressure at Y. Why? Because they are on the same altitude. Altitude simply means the height above sea level. On simple language, the height above the ground. That's why water will boil at 100. Pure water will boil at 100 degrees Celsius at a normal height or at normal sea level. But if you go on the mountain, the pressure will reduce. That's why mountain climbers, when they are climbing their mountains, they cook their food using pressure cookers, because when you go on the mountain, the pressure decreases, and most of the time when you cook on the top of the mountain, what happens that most of the time the food which you cook will be undercooked. Okay, I hope it's clear on that one. We move on to question C. So question C reads, the manometer liquid used in figure 5.1 is water. Its density is 1000 kilograms per meter cubed. Its length from Z to Y is 25 centimeters. Determine the difference in pressure at X and at Z. Okay, so here we're going to use pressure under liquids. So the formula pressure under liquids, we know that pressure is equal to what? Density. I'm just write the density properly. So we know that density, right, times gravity times what? Times height. That's the formula of pressure, and that's the formula for liquid pressure. So looking at the data given there, I've been given the density of of the water, and the height I've been given as well. The density, just write this here. The density I've been given is what? It's 1000, and the height I've been given is what? Oh, the height has been given in centimeters, so we have to convert that into meters. So how do we do that? Okay, let me just move this for space on top. Don't forget, the height has been given in what? In 25 centimeters. So how do we convert the 25 centimeters into what? To meters. Okay, we know that 100 centimeter is equal to what? 1 meter, right? Now we ask ourselves, what if we have 25 meters? So, what if I have 25 centimeters? I beg your pardon. What if I have 25 centimeters? What will be our meters? It will be x, we don't know, right? So to do the calculations here, what do? You can cross multiply. We're going to have 100 just get my pen. we're going to have what? 100 centimeters. X. Remember, Miriam, we have done what? We have cross multiplied with this one. Okay, so that's why we are getting this 100 centimeters. X is close to what? So we're going to also cross multiply with 25 centimeters with what? The 1 meter there. So when you do that, what are you going to get, Miriam? Right, you are right, you are very much right. You're going to get 25 centimeters. More this for space, just okay. 25 times what? That 1 m. Okay, so to find our answer here, what do? You're going to divide both sides by 100 centimeters. By 100 what? Centimeters. Also on this side, we're going to divide 100 centimeters. So that the centimeters, they can cancel what? Cancel each other out. So this one will cancel out, this one will cancel out, this one will cancel out, this one will cancel out. When you cancel out everything, Miriam, I'm going to remain with what? Exactly. Brilliant, bravo. We're going to remain with what? With our x on the left hand side. So here we can also cancel this centimeter, also these centimeters as well. Let me just move everything in front for space. So after we have done the cancelling, the cross multiplying with the units, on the left hand side here we're going to have x is equal to what? When you divide 25 by 100, you're going to get what? 25 divided by 100, you're going to get 0.25. Now remember, you have cancelled out the centimeters, right? So what unit are we going to remain with? We're going to remain with our hem, this one, that one there, which represents what? Meters. Wow, congratulations, Miriam. Have you seen? You have learned how to derive units. So this is also deriving units for meters. We have done that. You have learned how to convert what? Centimeters into meters. Okay, so now since we know our meters is 0.25 meters, we go back to the formula for liquid pressure. Keeping in mind that our meters is what? 0.25 meters. So going back to this formula here, we're going to plug in our values. Since we know that density have been given is what? If you remember in the question, have been given is 1,000. So we're going to say open bracket 1,000 close bracket, right? Multiply with our gravity, which is what? 10. The pull of gravity on Earth is always 10, guys. Don't forget. Then our height, you have found this what? You see, let me just remove that part for space. Open bracket. Okay, sorry about that. So we know that our height of our fan is what? 0.25. So we're going to multiply everything which is in what? In the bracket. So that we can get our what? Our pressure. So now let's multiply 1000 by 10 the power of gravity by 0.25, which we're going to get what? 2500. Miriam, what are the units for pressure? The one from deriving. Correct. Which is 25. This is 25. Oh, 25. This is 2500. 500 Pascal. That's how you find that the pressure. This is our pressure. Wow, thank you for watching the TV. I appreciate you watching my channel.